Hi guys, it's Simon C. Welcome to this new AI radar with my 3 favorite artificial intelligence news for today. Facebook joins the AI race, ARM chip for AI support and 5G, AI in sensor system on chip. The Financial Times says that Yann LeCun, Facebook's chief AI scientist and one of the pioneers of modern artificial intelligence, spoke before companies making next-generation computer chips at the IEEE's International Solid-State Circuit Conference on February 18th in San Francisco, USA, and presented a paper exploring the latest trends in deep learning. What emerged from his talk is that Facebook is racing Amazon and Google to develop its own artificial intelligence chips, in particular application-specific integrated circuit. After recognizing that it needs dramatically faster computing to deliver the next breakthrough in artificial intelligence, the company's goals include a digital assistant imbued with enough common sense to converse with a person on any subject, a significant step up from today's voice control devices, said LeCun. If there's any stone unturned, we're going to work on it, he said. Facebook's decision to create its own chips represents another long-term challenge to NVIDIA, the main producer of the graphics processors currently used for AI in data centers. Advances in how neural networks function are likely to heavily impact the design of the chips that power them, potentially opening up more competition to the companies that make today's leading AI chips. For example, Google's TPUs, Google's Tensor Processing Units, the most powerful data centers chips for machine learning so far, are still fairly generic, Mr. LeCun said. They make assumptions that are not necessarily true for future neural network architectures. Facebook wants also to use niche AI to help its army of human moderators decide what content should be allowed on the service. Maria Deutscher writes on SiliconANGLE that yesterday ARM unveiled its new Neoverse chips for data centers and 5G networks. The newly unveiled Neoverse N1 chip is aimed at loosening Intel's grip on the market. ARM claims that the design provides as much as 2.5 times more processing power for server workloads than the previous Cortex A72 architecture. The N1 is at least 60% speedier, and although primarily optimized for high performance, it's also achieving 30% more power efficiency than the Cortex A72 in the same chip-making process. Another area where the chip improves upon its predecessor is artificial intelligence support, says Deutscher. Indeed, companies almost always run artificial intelligence workloads on graphics processing units, which are much better suited for the task than general-purpose chips, but there are certain scenarios where ARM does see the N1 being used to this end. ARM claims that the N1 can run machine learning algorithms up to 6 times faster than the Cortex A7. In practice, speeds will likely vary significantly. The Neoverse E1, the second new product the company unveiled yesterday, says Deutscher, has a more narrow focus. It's designed to power systems such as cellular base stations that are specifically built to process network traffic. ARM is looking to capitalize on the massive hardware investments carriers are making as part of the global shift to 5G, the fifth generation wireless standard that promises to speed up mobile connections dramatically. The firm claims that the E1 transmits data up to 2.7 times faster than earlier chips, with up to 2.4 times higher energy efficiency. It also provides up to 2.1 more processing power for carrying out actions on that data, specifies Deutscher. Mike Wheatley for, again, SiliconANGLE reports that computer processor maker AI Storm has built an AI in-sensor system on chip that enables faster processing of complex artificial intelligence problems at the very edge of the network. The chip is designed to be integrated within the sensors that are embedded into mobile devices, Internet of Things machinery, and self-driving cars, processing data directly within them. The company reckons that by processing sensor data directly at the edge of the network, it can help to reduce costs and eliminate the security risks of transmitting large amounts of raw data to the cloud to be processed. Processing data at the edge is nothing new in itself, but the way that AI Storm does it is, points out Wheatley. Encoding this data into a digital format before AI system can process them is costly and time-consuming, and requires extremely powerful and power-hungry GPUs that aren't suitable for mobile and other lower-powered devices because they require continuous digitization of input data. But AI Storm's low-powered SoCs eliminate the need to transform data into a digital format because they process information directly from the sensors while it's still in its native analog form. The processed data can then be used reconsistently to train AI and machine learning models for a wide range of different tasks. AI Storm's technology should be able to speed up data processing and AI in smartphones, machine vision, AI assistants, security, and many other applications. Maybe NVIDIA should think about creating whatever processing units specific to the various requirements of new AI systems in mobile devices and at the edge. Okay guys, it's all for today. See you next time with AI Radar. Bye.